Good afternoon once again, and welcome to our webinar. Thanks for joining 5 Ways to Keep Chemistry Students Engaged and Prepared. I'm Allison Mortland with Realizeit, and our presenter today is Master Instructor Andrea Leonard from the University of Louisiana-Lafayette. Today's presentation will run about 20 minutes, and then we'll have time for your questions afterward. We will be recording the session and sharing it with you so you can review it later or pass it on to your colleagues. We encourage you to ask your questions throughout the webinar. You can do this by clicking the Q&A button on the bottom panel of your webinar screen or in the chat. So you can ask your questions at any time, but we will hold off on answering them until the end. So now it's time to get started. I'd like to welcome and thank Andrea Leonard. Thanks, Andrea.
Hi, thanks so much, Allison. So today I'd like to talk about an adaptive approach to chemistry education, or 5 steps to keeping chemistry students engaged, active, and prepared. So the most common student complaint that I hear, and I'm sure we've all heard a variation of this, is I watched every lecture. Everything seemed to make sense to me at the time. Understood everything, but then when I took the test, I failed. And an analogy that I like to make when a student approaches me with this situation is the riding a bike analogy. You watch your brother, your sister, your parents ride their bikes from the time you're a small child, and it seems so simple. They get on the bike, they push the pedals, they go. But the first time that you ride a bike, you fall. Everybody falls the first time they try a new skill because they need practice. There are so many skills, math-intensive disciplines like chemistry, engineering, physics, statistics, that require students to develop these specific problem-solving skills that they have to apply themselves. They're only going to learn them by practice over and over again. But often students don't receive this practice in class or out of class. The majority of students are content with their in-class work, and they rarely pursue any after-class practice unless it's graded. Now, how do I know this? Well, I looked at a class I taught in spring 2017. It was a General Chemistry 1 class consisting of 76 students, and I had ungraded practice links in the course shell on the LMS that I strongly recommended all the students click on these links and work through these practice problems. And what I found was that about 49% of the practice problems were actually accessed, less than half. And of course, this means that some students clicked on all of the links and some students clicked on none of the links. But when I tried to see if there was any correlation between the students clicking on my practice links and the students' grade in the course overall, I saw that there was very low correlation. My y-axis here is the percentage of ungraded practice links clicked on, and the course grade is my x-axis, and I can see that the data is all over the place. And what I gained from this is that even if students are clicking on those links, that does not necessarily mean that they're working through any of those practice problems. And I wanted to know why. Well, I think number one, they have a false sense of security. Again, that riding the bike analogy. They've seen the lecture videos, they've seen what I do in the course, and it looks simple, and they feel confident in their understanding of the skill without actually practicing the skill themselves. Second, there's no feedback in a textbook. If you get an answer wrong, you're going to be told what is the correct answer, and usually that's about it. So understanding, was the textbook wrong? Was I wrong? How to do it correctly? You don't get that with the textbook, and the students end up with this feeling of being lost and confused, and they kind of shut down at that point. We also can't forget that there are some students that just simply cannot afford a very expensive textbook. Even to rent the textbook is outside of their price range, or they're waiting for their benefits to come in, and those benefits have not come in yet, so that they can't get started on time with everyone else. Now remember, this practice is ungraded. So what would happen if I made the practice worth some sort of point system, if I did graded practice? And the most convenient way to check graded practice is with an online homework system. So what I'm doing here is I'm comparing the same exact course with a graded online homework system from a known publisher, and how did they perform on their online homework grade compared to their overall course grade on the x-axis. And what I saw was they did quite well. It's a very much more correlated data. My R² value is 0.6, which is high, but ideally we'd like it to be closer to 1. But again, I still see some outliers. I still see students whose online homework grade is quite low that succeed in the class, getting a 70 to 80%. And then those students where the online homework grade is quite high, but unfortunately they've earned a D or an F in the class. So I want to try to understand, why isn't the online homework helping them more effectively? And I think it's because the traditional online homework systems tend to value correct answers over student understanding. The students are given a limited number of questions on each topic. Most of the questions are the same every time the student attempts them, so there's no variety, there's no variability within the question itself. And this means that the students tend to look for other sources of the correct answer rather than actually practicing the skill. So they tend to search the internet for the correct answer, work the problems through with their friends, and everybody sort of crowdsource the correct answer. The minimum amount of effort is rewarded in these traditional online homework systems because the correct answer is so easy to attain in other ways. Also, I noticed that this online homework system comes with a very high price tag. Again, looking at my students that cannot afford a textbook, to also add another $120 to $140 on top of it for an online homework system really seems to be unfair for everyone entering the course at the same sort of financial level. So what we looked at was an adaptive learning platform to teach General Chemistry 1 that would address some of the issues that I was seeing and hopefully make students more test ready. So number one, I want the platform to emphasize practice. Number two, I want the students to have immediate feedback on that practice so they know how it relates to their class as a whole. Number three, I want the students to have more control over their learning path rather than one topic at a time. Number four, I want to be able to know the exact right time and the exact right person to contact as an instructor, so helping instructors to help students more effectively. And number five, I want to be free from the textbook and the costs and the limitations that come with that. So looking at solution number one, emphasizing practice, we're using a platform called Realizeit that is an adaptive platform, and it makes practice an integral part of every single lesson. So I'd like to start with an image from the LMS. We use Moodle as our LMS. And you can see that the students just click on the link within the LMS. They're taken directly into the adaptive learning platform. There's a single sign-on for this platform, so it's easy for them to know what to do next. The top of the screen shows you what you have achieved so far within a unit. The course is split up into individual units, and those units are then split up into individual lessons based upon learning objectives developed by the chemistry department here at my university. So we know what we've done so far, and then the student knows their current composite score. And then at the bottom, they're clearly instructed what should you do next. And what they should do next is to learn this specific lesson. There's also access to a learning map, which we'll discuss later. So the student is supposed to learn this specific lesson within this unit, and they'll click on the link that says learn, and they'll be taken into the lesson itself. Now, first as an introduction, where we introduce the learning objective for this lesson. Followed by that, the lesson includes a video, which they can watch if they choose to. If they need an alternative version of the video, they can access alternative content, which is simply the text that the video would contain for anyone needing transcripts of those videos for accessibility purposes. And finally, we have questions. Every single lesson includes questions. The questions appear on the same screen as everything else, so there's no reason for students to need to go to a secondary source to do their practice. It's all included in-house. The questions are written for my course, I got to write all of the questions, but many of the pre-made courses already have questions that are written. And the student is also informed that they're going to be asked 8 questions, and they'll be informed how many they got correct. Now, getting questions correct is important, of course. I don't know why that's happening. There we go. Because the student cannot proceed to the next lesson without answering 70% of those practice questions correctly. And the 70% value is set by me. I could lower it to 50%, I could raise it to 90%, but I've set it at a C level. If the students can get a C on all 8 questions, then they can proceed to the next lesson. but they cannot proceed unless they've practiced this one skill effectively. Then if a student would like to have a composite score of 100% on the lesson, they can absolutely always go back and repeat the lesson to improve their score. I wanted to show you what that looks like. Let's say I worked through one of the lessons and I was asked 8 questions, and unfortunately I only answered 4 of those 8 questions correctly, which is a 50% correctness. The platform is going to tell me that this lesson is not complete. I haven't demonstrated enough knowledge of this topic to mark it as done, and I will have to refresh it. So I go back, I watch the video again. Maybe this time I access the textbook or look at some of the alternative content. And this time I answer 8 questions and I get 7 of them correct, which is 87.5%. So my lesson is marked as complete. I can now move on to the next lesson if I have time. But I wanted to point out that the program tells the student my initial understanding of your knowledge state is 45%. Just because I earned 87.5% of those questions correct does not mean that I understand this topic at 87.5%. It just means that this time I happened to get those questions correct. So what I want to point out is that I can always go back, revise this lesson, and improve this understanding of the knowledge state score so I can get it up to 100%. So practice questions are pulled from a large pool written by me in this case. Every single question that I wrote includes either a mathematical variable or a text-based variable, so that even if a student gets the same question again, they're going to see a different version of that question every time. And this means that the students aren't going to be able to, go through 8 questions, get them all wrong, but write down the correct answers, and then go through a second time and input those correct answers. That can't happen. They're not going to be able to memorize the questions. They're going to be able to apply their skills. So the effect of emphasizing practice is to first remove the illusion of sufficient practice, because the AI tells them what is their current knowledge level, and it's not going to be 100% the first time. And second, students have a more realistic idea of how prepared they'll be for my test. So moving on to the second solution, giving immediate feedback. It's very important to me that if a student gets a question incorrect, there is some feedback on the page to show them why it's incorrect. And I want to show you what this looks like in an actual question. So here's one question from a different topic than earlier, wherein they're asked to type in a mathematical answer. So I've gone ahead and pre-typed in this mathematical answer, which of course I'm told is wrong. And then if I'm only told, unfortunately, this is not correct. If I'd like more information, I can click on this little button that says View Solution. So again, I don't have to go to an outside source to see why my question is wrong. It's all in-house. And then a solution appears that tells the student first what is the correct answer. Second, links us to language from the learning objective for this lesson so that the student knows exactly which topics they're getting incorrect here. And third, shows them the exact mathematical setup necessary to solve this problem. So they can either compare it to the setup that they've written down, or if they did not choose to write down a setup, they can see the value of using a setup to solve this type of problem. Next, students can flag questions if they need more explanation or if they think that they are correct and the program is wrong. And this helps instructors to know which students are flagging more questions and which questions are flagged the most often. So the flagging process is very simple. Within my incorrect question, I will see a little flag in the upper right-hand corner. You cannot flag a question unless you get it wrong. And when the students click on this, they're informed that it's going to create a message to send to the instructor. I, as the instructor, get not only the question text, but also what the student entered and what the correct answer was. So I can generate a message specific to the student for this issue. And the student doesn't have to go into an email and open it up and try to explain to me what happened. It's all very streamlined here. So the effect of giving immediate feedback is to first reinforce the link between the learning materials and the practice by using language from both. And second, to remove the uncertainty as to why an answer is incorrect. If it's not apparent in the solution that's on the screen, they can flag it and send a message to me so that I can make it more clear. The third solution is to give more control of the learning path to the student. So each unit is going to give the students a learning map containing every lesson within that unit, and it contains the relationships between those lessons. We usually teach chemistry and most topics kind of like a freight train, one topic after the another coming at you, and you can't really change paths or learn something different. You have to learn them in the order that the instructor provides them. And now I can provide them more of a choice. So this is a picture of what the learning map looks like coming from the student's main entry screen. There's always the what you should do next portion, but maybe I would like to see what are all the lessons that are available. So in that case, I'll click on the learning map. And the learning map is going to show me all these wonderful tools. All of the lessons are represented by little circles. I can see that some circles are locked, which means I have not completed the prerequisite lessons for those. And some circles are available. If I'm wondering what I should work on next, it's got this beautiful blue circle around it to let me know this is the lesson I should probably work on next. And I can just click on it so that I have immediate access to that lesson. Also, my performance in the lessons is gauged by the different colors that the circles turn. My beautiful green star circle means I have a 100% knowledge of this topic. I don't need to review this topic before my test. My yellow circle means I should probably go back and revise or practice this skill before my test because I'm probably not going to do so well. And my red circle tells me, no, I have no knowledge of this skill. I really need to go back and revise this particular lesson before the test or I'm going to get those questions wrong. So you can also see that there is different pathways that students can follow. This particular student has chosen not to click on the link that was recommended, calculations with significant figures. Instead, they've chosen to work on scientific notation and SI base units and prefixes. I don't know, as a diversion to not do significant figures. I understand that completely. But eventually they will have to do every single circle in the list. So the effect of this learning path is students have a visual guide to their course progress. And it's really easy for them to see which lessons need more attention, which lessons should they do next, and finally have the knowledge when they are done and prepared for a test. Solution 4 was to help instructors help the students. It can be difficult depending on your LMS to know how students are progressing in the class and to know which students need help when. And that's what this adaptive platform does really well. For an individual student, it will give me an accurate picture of their progress in the class so far. So let's say I had a student, Bilbo Baggins, that I'm concerned about. I can click on Bilbo Baggins within the adaptive platform and get sort of a snapshot of what Bilbo Baggins is doing. The current unit that Bilbo Baggins is supposed to be working on, I can see that he has completed 2 out of the 6 lessons within this unit. Oh dear, I can see that the group average on this unit is 5 out of 6, so definitely Bilbo Baggins is falling behind. I can see that of all of the 6 lessons, the 2 that he's completed, he's not gotten a green circle on any of those, so he definitely needs help. I should probably reach out to him and speak to him about acids and bases. I think that'd be a good place to start. But I can also see that yesterday, Bilbo Baggins was working on concentration and titration, which is not a lesson in the unit that he should be working on. So he's definitely falling behind. I, as an instructor, need to reach out to Bilbo Baggins and determine where he is in the class and how I can help him. The second thing the platform does is give me an access to each problem answered and time spent. Let's say that Bilbo Baggins was working on one of those lessons and he just can't get any of the answers right, poor darling. He's been trying and trying. So I can look at every single question that that student has answered, and we can use these questions as a jumping off point to talk about the theory involved and the problem solving skills that he's just not seeming to get yet. I can also use this as an opportunity to stress problem setup. For example, a question like the one that I've circled, it seems that Bilbo Baggins took only 12 seconds to answer that question. However, I know that that question has a serious mathematical setup that the student would have to do in order to get it correct. And he has chosen, obviously, not to do that. So I can emphasize the need to set up his mathematical problems, to make sure that his units cancel, etc., by looking at how much time Bilbo Baggins has spent on the very difficult questions. And the third thing that the adaptive platform lets me do is identify students that are falling behind in the class as a whole. So if I'm just looking at the big picture from an instructor's viewpoint, I will see this screen. I'll see in the unit called acids, bases, and electrolytes. How is the whole class doing? Well, I know that 5 students have not yet started. Oh dear. So I'm gonna need to send them a message. By clicking on the link that says send message, I immediately generate a message to those students. Again, I don't have to open up a secondary email browser. I also can see that as a whole, 8 students are working behind. Now, this is not the same thing as not started. Not started means haven't done anything. Working behind means maybe they've done 1 unit while everyone else has done all 6 units. So I need to address these students, make sure that they understand that time is passing and that they don't want to be working at the last minute before the test to try to get these correct. So the effect is to increase effective instructor-student interactions. I know who needs help and I know exactly what they need help on more effectively. And it also decreases student isolation. If a student is falling behind or feeling lost, they might not want to reach out for help for whatever reason, but I can reach out to them. And finally, the 5th solution is freedom from the textbook. So this class uses the OER Text OpenStax general chemistry textbook. It's available for free online and it is editable so that if I see a topic that I think could be discussed a different way or a term is used that I don't care for, I can change that. And this removes the cost from the student burden of higher education. No longer are we waiting for checks to come in for students to begin their coursework. They can begin their coursework immediately. This also means that the homework questions that the students work graded questions that the students work are not limited by the publisher's online homework system. I have infinite freedom to add questions, add variability to my questions, change how the answers are inputted by the students, and this makes for a huge amount of practice problems that the students can pull from. And finally, I have, as an instructor, have the freedom to cover the topics in the order that I decide is more important, not the order that the publisher has decided the chapter should come. So I wanted to give you an idea on this slide about how the OER text is integrated within the lessons. Instead of just providing students with the link and saying, yeah, here's the textbook, click on it when you need, within their lessons, there's a little circle at the upper right-hand corner with a plus sign that says extras. This will take you to the textbook, but not just the textbook. It'll take you to the specific page within the textbook that this lesson is discussing. So since the lesson I can see here is about measured numbers and units, when I click on that textbook link, it should take me to, measurements. Section 1.4 of the textbook is about measurements and units. So it's very convenient for a student to get access, the exact right access to the textbook at the exact right time within their learning path. So the effect of freedom from the textbook is that the course is really designed by the instructor, the topics are in the order the instructor has decided, and the language used is what the instructor deems most appropriate to the class, not what the publisher deemed most appropriate to the class. And then all students have equal textbook access. We are not limiting students' ability to learn by their financial situation. So how did this go? I ran this class using the adaptive coursework in fall 2018, which is the graph that I'm showing on the right here. And I'm comparing it to the graph that I had on the left from spring 2017's online homework grade versus overall course grade. Do you remember from that graph, my R-squared value was 0.62. This, again, we had roughly 76 to 78 students in each of these classes. So these are fairly high population classes, but they're nowhere near the 300 student population classes that I've seen before. In my fall 2018 class, I saw a much better correlation between the grade students earned on their adaptive coursework, which is graphed on the y-axis, and their overall course grade, which is graphed on the x-axis. My R-squared value was 0.77, which is much closer to 1 than before. So when students walk into a test, they pretty much know what grade they're most likely to earn on the test based upon what grade they had from their adaptive coursework. So definitely practice affects performance in my course. Because the emphasis is on practice and knowledge, I found that the adaptive platform is much more predictive of course performance in a whole. Students can see the relationship between their score on the adaptive platform, which was again called Realizeit, and their score on the test. So real data that's effective. And finally, I had lower prices of both the OER textbook and the adaptive platform had lower prices than the traditional online homework. So this helped to remove financial barriers for my suffering students. Now, what are my next steps? Well, first of all, I want to branch this out. So I have only taught this course once so far. I need many more sections to be taught and to be taught by different instructors. I want to see what other instructors will do with this information. This includes other instructors at my university and licensing this product to instructors at other universities to see if we can get the same results. We're also interested in working deals with high schools in the area to use this course as a dual enrollment course so that high school seniors can earn college credit. Next, I want to include some synchronous activities. This class that I've been running is technically a hybrid class, and I think that that would increase student-student interaction and student-instructor interaction, and I would like to see the effect of that. Finally, the number and type of practice questions has to continuously be increased. I feel very passionate about that. And at the end, we're going to start writing General Chemistry 2. So far, we've only done a General Chemistry 1 course. And the beauty of the platform is that it can be tied into the General Chemistry 2 course. So if a student has an issue with a subject in Gen Chem 2, they can go back into the Gen Chem 1 information that they've learned before. And I want to thank everyone for joining me today. I had a wonderful time in this talk.